Okay, so the topic of my talk will be about how to decarbonize the transport sector through e-fuels. Okay, so I won't go very much into the details of the market drivers. I think you are all familiar with that. So we need to decarbonize the industry by using CO2 and trying to mix it with renewable hydrogen so that we can make clean fuels. There are very strong commitments that we need to address. The issue is timing, especially for sustainable aviation fuels. We already know that the targets will be very challenging to meet. So we need all possible technologies to do that. So what is Khimod? So I don't think many of you are familiar with this company, and this is for a reason. So Khimod is a startup firm, so as you can see on my badge, but it's not really a startup firm. In fact, it's a spin-off of the Alsan group, which is a medium-sized industrial group in France, working especially in the defense and the nuclear industry. And in these sectors, people do not like to talk a lot. So that's why things have been kept secret for a long time. So we're not a startup firm because there is 20 years of R&D behind that it's been applied in strategic defense. Okay, better now? Okay. Okay, it's interesting to notice because in this sector, failure is not an option. So we like to make things that work. And since basically 10 years, we've been working on pilot scale projects in various types of e-fuels, especially on e-methane. Okay. Oh, it doesn't work. Okay, sorry. No. Okay, so what do we do? So we are an equipment manufacturer. We manufacture this type of heat exchanger reactors. They have something particular, is that they have a very tiny catalytic beds. And as you can see on the other side, we have microport that allow to have another cooling fluid and to have a very close control of the temperature profile in the catalytic bed. Okay, this type of very compact reactors take CO2, and this CO2 can come from either the industry or direct air capture, or it can also come from various types of biomass. So there could be a strong combination with biofuels. The other important feedstock that we need is hydrogen. We like to have it green. It can also be blue. And by combining CO2 as a carbon source and hydrogen as an energy source, we can make different types of molecules. So our technology can handle almost any type of catalytic reactions. Of course, because we have a strong control of the temperature profile, it's more suited for highly exothermal reactions that we can encounter in the Power-to-X sector. So we are focusing especially on three types of molecule. As I already mentioned, the Sabatier reaction, so making synthetic methane that you can directly inject into the grid. I mean, it's directly from the reactor. There's no need for further process treatment to inject it into the grid. You can also liquefy it and then use it as LNG, which is also an energy form that is used by the marine sector. So this is the history of the company. Since 10 years, we've done I think 8 or 9 pilots of e-methane. But nowadays, the focus since 2 to 3 years is more on methanol and e-crude. Methanol for 2 reasons. One is for the decarbonization of marine transport, because the methanol is the easiest fuel to replace traditional bunker fuel. You don't need very heavy modifications of the engines as you would need with other fuels like ammonia, for example. And there's also a very strong push from the chemical industry, especially the German chemical industry, because it is seen by major chemical companies as an alternative to natural gas. And I think you are all familiar with the context of the shortage of natural gas with what we're seeing now with the war in Ukraine. The other type of fuel is e-crude. So e-crude through the Fischer-Tropsch reaction. So Fischer-Tropsch is not a reaction; it's a family of reactions. It can produce various types of crude. People are mostly interested now in middle distillates, in jet fuels. But of course, it produces a lot of different things, like naphtha, which is interesting for the chemical industry, and also lubricants. Okay. So what is the core of our technology? So the core of our technology is diffusion bonding. So we have a series of patents developed from the nuclear and defense industry about controlling diffusion bonding in order to make these types of reactors. So the smallest one that you can see here is called the K1. It's typically the size that we use to make pilots and to test different chemical reactions. The intermediate one is the K3. It's typically what we find in containerized pilot process units. And now we are gearing up to make a larger scale up to the K10. K10 is roughly 1 meter cube by 1 meter cube by 1 meter by 1 meter by 1 meter, so 1 meter cube. To give you an idea, we need around 5 of these K10 to produce 1 million ton per year of methanol, for example. So we have a small factory in the suburbs of Paris. We are now in the process of automatizing this plant in order to produce more of these reactors with a high level of quality. But that's not it, because today we have customers saying, "Oh, this is very nice what you're doing. Can you do the same thing but multiply the flow rate by 100?" Yes, possibly, but in order to do that, we need to produce more and larger units. So that's why also we are searching for funds in order to increase our production capacity. Okay, another thing that we can do also in this facility is that we build containerized units, so that we can test our various processes. Okay, I will then focus more on e-crude. So we are one of the few companies who have experience in e-crude since 2017. So before it was even something that people like you would, most of the people like you would consider. This project is actually finished. It was a European consortium, and we've built a facility in Austria where we tested our reactors. And the good thing is that it works. It produces e-crude with a high yield and high selectivity on diesel and jet, so which is the thing that people are interested right now. So now we have another project, which is a little bit the next step, which has just started with a French company called Elise Energy, who's a project developer in the Power-to-X sector. Now we are in the process of industrializing this process and integrating it with two other reactions. So the reverse water-gas shift, is the reaction that allows to transform carbon monoxide into carbon dioxide. Since we want to use a feedstock which is not clean CO2, so this feedstock is actually CO2 extracted from a biofuel production unit, so it's not very clean and not pure CO2. And another thing is that we want to also to combine it with reforming, because people are generally not really interested in the light ends, so they want to convert the light ends back into carbon dioxide and hydrogen in order to increase the yield in middle distillates. So this project has just started, and next year there will be a pilot plant that we will build in our facility close to Paris, combining these three bricks. Okay, so what is the advantage of our solution? There are many advantages. It can withstand very high pressures and very high temperatures. Very high pressures is interesting because all these reactions occur in the gas phase, and of course, if you increase the pressure, you increase the throughput. Okay, the thing is, and we don't generally see a very big degradation in the conversion by increasing the pressure. One very big advantage is that it's perfectly modular, so we can make it small size or big size, but it doesn't change much in terms of process. So there is not a long period of time required in order to scale up a process. We can start small and then directly build something bigger. Of course, because we have very tiny channels, we require not a lot of a catalyst. That allow us to have very expensive catalyst, very expensive, very selective catalyst, with a good thermal regulation. Okay, this is all technical, you may ask, but why does it make sense? Well, if you can have the best possible use of high-end catalyst, you can make sure that you can also have the best possible use of your feedstock. And if you look at the balance sheet, what is very important in terms of cost is the hydrogen feed. It represents 70 to 80% of the final cost of the product. And if you can decrease the hydrogen consumption by 10%, it has a huge impact on the capex of the plant and on the overall LCO of the product. And that's where we try to compete with very promising results so far. Okay, so a word about our business model. So basically we are an equipment manufacturer. So we manufacture this type of equipment for chemical firms that have experience in flow chemistry. So we work with companies like Sumitomo, BASF, and so on. So this is for the people who know what they're doing. But most of the times people are not requiring equipment, they're requiring solutions. And in order to do that, either we can supply the full package in containerized units, or we can partner with engineering firms and large-scale utility companies to make large plants that don't fit into containers. We don't want to be an EPC contractor. We want to focus on our core business, and then we would then focus on the catalytic reactors and working with others to make the balance of plant. So that's it for my presentation. If you want to know more, please don't hesitate to come to our booth downstairs, and I'll be happy to answer any questions that you may have.